In this video, we're going to look at moments. Now, the moment of a force is defined as a measure of the turning effect a force has upon an object. So we've looked about particles so far, so we've been talking about particles, but now we're going to look at objects such as beams and rods and all these sorts of different things where you touch the force makes a difference. So if you touch it in the center, it maybe makes a difference than if you touch the beam at one of its extremities, so one of its ends. So we're going to define a moment of a force as the moment is the force times d. So that's where F is the force acting on an object, and D is this is very important. D is a perpendicular distance from a point to that force. So that's what D is. And the units of the force are nm, which stands for Newton meters. So Newton meters is the units of force. So newtons 10 meters. So if you think about why that is, think about what we just said. Units of force are newtons, units of distance then are meters. So units of moments are going to be Newton meters. Note that moments have direction, so that means either clockwise or anti-clockwise, and always state the direction of the moment. Okay, we're going to do this one. It says calculate the total moment about O. So this first one, it says calculate the total moment about O. And if you imagine, you've got this. This is your point O. 1.5 meters away, you've got this 3 Newton force, and you think, imagine if that force was applied, it would be going around this direction. So it's clearly going, that would be anti-clockwise. So how we denote this, sorry, you're going to have your O, and then what you're going to say is, do this wee symbol, just O with the wee arrow going around anti-clockwise, and that means, and that's recognized as, take anti-clockwise moments about O, which means anything which is actually going anti-clockwise, which has a turning effect anti-clockwise, you treat it as positive. Anything which is going the other way, so clockwise in this case, would then have a negative moment. So take moments anti-clockwise in this case. Our force is 3 newtons, and look, it's already going perpendicular. So the force, remember, it was F times d, where the force and its perpendicular distance. So in this case, your moment is going to be 3 times 1.5, and 3 times 1.5 is going to be 4.5, and the units, remember, are Newton meters. And say you have to say the direction, put in brackets, the direction is ACW, which stands for anti-clockwise. Of course, if it was just CW, that would have stood for clockwise. Okay, sometimes when you're doing these, you will make if there's not one like this really, but if you would make an incorrect assumption, you maybe think, I reckon overall the system of forces is going clockwise. So maybe you worked it out, and after working something out, you got minus 7 Newton meters clockwise. So maybe you worked that out. Now, if you got minus 7 Newton meters clockwise, you would know then to write that as that's the same as 7 Newton meters anti-clockwise. So if you do make the wrong assumption at the start, just correct yourself at the end. Okay, and the last example for us in this very quick video, we've got this force, we've got this system here. So there's 3 forces involved, and they're going in all different directions here. And we want to look and see what we think it's going to be. So I'm going to assume here, I'm going to think that they're going, I've got this one would be going anti-clockwise, and this one would be going clockwise, I should have said. This one would be going anti-clockwise, and this one as well would be going anti-clockwise. But they're smaller. The ones going anti-clockwise are smaller, so I'm going to guess ones going clockwise, I should say, are smaller. We'll do this. I'm going to guess anti-clockwise here, actually, or for this one. So I'm going to say it's going anti-clockwise, and we'll see. I might be wrong here, and if I'm wrong, we can just correct it. So here, so this means I'm taking a moment anti-clockwise. So anything going anti-clockwise, I'm going to take as positive. So let's do the positive ones first. We had this one. First of all, we had the 2.5 newtons, and it was 3 meters away. So that's that is 2.5 times 3. Okay, the next one, we also have got this 1 newton, and it's 4 meters away. So plus 1 newton, and it was 4 meters away. And then the last one, which is going against us, is a 7 newtons, and it was 2 meters away. So that's going to be minus 7, and it was 2 meters away. So we'll tidy that mess up. 3 times 2.5 is going to be 7.5. 4 times 1, or 1 times 4 is 4. And then minus 7 times 2 is minus 14. So you can see I was wrong. And then if we do that, if we just do that, we've got 7.5 minus 4, plus 4, 7.5 plus 4 and minus 7 to 14, and that gives me minus 2.5 Newton meters, and I was assuming that was anti-clockwise, and you can see I was wrong. So you just change it, so it's actually 2.5 Newton meters clockwise. So that whole system, this whole system here that I'm circling, that whole system is equivalent to just 2.5 Newton meters, a turning effect of 2.5 Newton meters clockwise. And that is us done for this video.